Hello everyone, my name is Mohammad Darab and this session is titled Big Data Clusters for the Absolute Beginner. I'm honored to be part of this lineup, this amazing lineup at IT Pro Dev Connections 2020. I am presenting virtually to you and I'm just very thankful for the opportunity. I hope everybody's keeping safe and doing well. I want to give a big shout out and a big thank you to all of the sponsors that make events like this happen, specifically this one, because now that it being the pandemic and a lot of people are on lockdown and cannot attend these type of events in person, for these sponsors to come out and still promote these sessions to be able to do it virtually, that still shows huge kudos to those companies, and I do wanted to just take a time to thank them. Now, the URL that you see on the screen right there, mohammaddarab.com/BDC, that is my personal blog, and I blog mainly about big data clusters. But if you go to that URL/BDC, you will see everything that I'm talking about here. So this presentation and a couple other things I will mention, you will find that at that link. So you can just sit back, relax, and as they say, enjoy the show. So, big data clusters for the absolute beginner. If you are like me, you are either a database administrator or a data professional, and either in the past or maybe even now, you are working with outdated technology. And you probably have Twitter, and or have some friends that are working with current, cutting-edge technology. And sometimes you might feel like your skills are becoming irrelevant and becoming outdated. This session, and my goal for this session, is to introduce you to the underlying technologies that make big data clusters happen. We'll talk about big data clusters. So by the end of this session, you will feel pumped up and passionate about pursuing cutting-edge technology and becoming relevant again. Not only now, but 3, 5, 10 years from now. So that's the goal. I hope you are at the end of this session as excited as I am over the past 2 years putting this together. So a little bit about myself, a little bit more about myself. Been working with in IT for a little over 20 years, 10 years of that, going on 11 years now, working with SQL Server. I started out as a SQL Server developer, then I quickly switched over to a DBA. This past July 2020, I was honored to be awarded the Microsoft MVP in the data platform category, and primarily due to my work and my advocacy and promotion of big data clusters. Shortly after that, in July and August, from August this year, 2020, up until September, I went head down and I studied hard. And I passed the 2 Kubernetes certifications. That's what you see right there. CKAD is the Certified Kubernetes Application Developer, and the CKA is the Certified Kubernetes Administrator. Now they actually have a new exam out. I believe it's a CKS, which is the Certified Kubernetes Security or Security Specialist or something. That excuse me. That just came out, I would say, in the last month, and I plan on taking that in 2021. Moving down, IDERA ACE 2019. If you are familiar with IDERA, the company, every year they sponsor a group of individuals in the tech community, and I was part of that class of 2019. I was honored to be that class. And again, online you can find me at mohammaddarab.com and on Twitter. If you're on Twitter, feel free to reach out. Now, this is a pre-recording, so if you do have any questions, I would like to implore you to reach out to me. Go to my website, contact, send me an email, follow me on Twitter, send me a DM, and ask me any question you want about big data clusters. Just in this past week, as an example, I had 3 people reach out via email. They went to my website, they reached out, they had a question about big data clusters that they're trying to implement in their own organization. And it is a test environment, so they have a couple deployment questions, and we kind of go back and forth and we're trying to work things out. So feel free. I'm always open to questions and assistance. So the agenda, and I'm going to do a quotes around this because I like to tell a lot of stories, and I feel very, very deeply and strongly that through stories we can connect. Through stories we can connect and pass on our experiences a lot better than just even a blog post sometimes. Sometimes if I just talk to someone and they'll pick it up fairly quickly rather than reading a blog post. So we're going to talk about the history, what is a BDC, the architecture, features, licensing and cost, and then I'll leave you with a learning path. So when you're done with this session, you have a link, you have something you can go do if you're interested. So this is not one of those sessions where at the end, it's kind of like, all right, bye, download the slide deck, bye. No, no, no. I will leave you with the learning path. You can go and pursue further your education with big data clusters. So let's get started. So let's start with the history. Back in 2016, if you remember, SQL Server introduced a feature called Polybase. And if you are not familiar with what Polybase is, all it allows you to do is connect from your SQL Server, your relational data, using your SSMS, for example, and connect to a big data source, in this case Hadoop. So you can read big data from Hadoop. They had connectors for Hortonworks, Cloudera, and Azure Blob Storage. So you can, with T-SQL, doing your select columns from a table, from a Hadoop source, a big data source, a non-relational source. And the beauty about it is that you don't have to do anything in the background. You don't have to learn how to code or do any type of Hadoop language. You just regular T-SQL, and part of the Polybase engine, it would translate that in the background for you and bring the data back to you. So that's pretty cool. But I remember in 2015 when I actually started reading about this feature, I was working with technology that was literally SQL Server 2005, 2008. So this was long down the road. Now, majority of people are using 2016, but back in 2015, it wasn't the case, especially from where I was working. So I remember reading about this and understanding. I was like, okay, that's cool, but it really didn't apply to me. So in 2017, if you remember, moving on to the year after that, Microsoft announced that you can run SQL Server on Linux, which was big. And I remember when I first heard that, I thought, why would anybody run SQL Server on Linux? I just did not understand it. SQL servers with Windows, they should be on Windows, and I need to see the GUI and the click next and all that. I don't have any experience with Linux. Why would anybody do that? But we'll talk about why later. Another point is that since you can run, or SQL Server was supported to run on Linux, you can actually run SQL Server on containers running on Linux. And we'll talk about what containers are in a couple more slides. So fast forward to 2019, they had, in SQL Server 2019, they had something called Enhanced Polybase. What is that? So if you look at the image right here, let me bring in the mouse over here. So if you see big data, starting from the right-hand side, you had your Cloudera and Hortonworks connectors back in 2016 when they created the initial Polybase. So for Enhanced Polybase, what did they do? They added the Spark engine connector, and for relational databases, they added the ability to connect to another Teradata, Microsoft SQL Server, and Oracle. So that's pretty big. The Oracle piece right here was even bigger. Wow, you can sit from your SQL Server, connect to Oracle via this Enhanced Polybase, and query all the data from it, or whatever data you need, and bring it back to your SQL Server. Pretty interesting. So, and moving over to the left here, NoSQL, MongoDB, or Azure Cosmos DB, you can connect to those as well, and also your ODBC connections. Very interesting. And I remember thinking, that is so cool. You can connect to an Oracle server and just select data from it. You don't even need to, boot up an Oracle server and know anything about Oracle. You just do it via T-SQL. Very cool. They also introduced the ability to deploy an AG, or an availability group, on Kubernetes. Now, if you don't know what an availability group is, do not worry. It's Microsoft's high availability, in some cases disaster recovery technology, but of course it being primarily on Windows framework, and now you can actually run it on Kubernetes. And if you're wondering what the heck is Kubernetes, we're going to talk about that too. So one question I do get a lot by now, and I want to address that, is what's the difference between Polybase and link servers? So here, this was taken from the Microsoft documentation website. I have the verbiage here in case you were to download the slide deck. You can go back and look and read for yourself. But pretty much the gist of it is Polybase is intended as a database scope technology and is suitable for analytic queries processing large number of rows. Now, link servers, on the other hand, instance-wide or server-wide scope, and ideally for OLTP queries running single or few rows. Now, link servers have been around forever, and usually around this time I ask the audience, how many of you all have worked with link servers? And a lot of hands go up. A lot of people have worked with link servers. It's been around forever. And then I ask the same people, how many of you all love working with link servers? And then the hands go down. Because it can be very troublesome and cumbersome trying to troubleshoot link server errors, connection errors, timeout errors. It just can be a pain in the butt. I work with link servers, and I just despise it. Whenever there's a link server connection, I'm like, oh my goodness, what am I going to do? The choices are very limited. But yeah, those are the differences. Now let's go ahead and get into containers, because I mentioned that. So in a nutshell, containers is a standard unit of software that packages up the code and all its dependencies. So the application runs quickly and reliably from one computing environment to another. So what does that mean? That means, imagine if you have your application and you have all of the files needed, the DLLs, all types of, imagine a Java application or your Go application, anything that has all of its dependencies together. And you put that into this container, this logical grouping of all of these services, and then you run that application. You can run it, you can access it. Then you can pick that up, that container, let's think of this container, and put it on a different machine, a different server. It could be dev, test, production, whatever. Same OS though. So if it's a Linux, it has to run on a different Linux machine. You can't run it on a Windows. And everything is running fine. So that's the beauty about it. Now you might be wondering, well, what's the difference between containers and, for example, a VM? Now containers is a little bit more fine-tuned. So you can have, for example, let's look at this image right here. And I took this image from Docker. And one thing I want to mention right now is you might have heard of Docker containers. And if you have not, I can assure you that from now on, you'll start seeing that everywhere. But Docker is the company. So you have docker.com. Now Docker creates this container runtime engine, and you can download it based on whatever OS, Windows, Mac, Linux, you can download it. They have the enterprise version, of course, a paid version, but you also have the free version. So what this does, it runs as a service on your OS. So let's look at this image right here. You have your infrastructure. So this is your server, your bare metal server. You install, let's say, Ubuntu. You install Linux Ubuntu on here. You download the Docker container runtime engine for Ubuntu, for Linux, running on this, your server, and it's running as a little service there, utilizing all the memory, the network, everything, just like a regular server. It's just running, very lightweight. Now, if a developer comes up to me and says, I need an instance of SQL Server up and running, I need to test something very quickly, I can, with a single command, Docker command, create one instance here. You see app 1 or app A. This will be SQL Server instance running. and they can go ahead and come in and test and play with it and break it, whatever they want to do. And let's say at the same time, or maybe a couple minutes later, another developer comes and wants to run their own instance. And a applied data scientist or a data analyst wants to come and have their own instance play around with. You can create multiple instances, A, B, C, D, very, very lightweight. Each one is segregated, doesn't touch the other, and you can create them within maybe even, I would say, if you were to download the image file, which would take the longest time, maybe a minute or 2, 3 minutes, the actual creation of that SQL Server container would be a matter of seconds. Can you believe that? Instead of creating a whole new VM and installing Windows and getting all the updates and then SQL Server and then create the updates, you can just do, which will take hours, you can just do this in a matter of seconds. Very, very simple, very, very lightweight. And that's why it's primarily used for continuous integration, continuous deployment, create, destroy, and this continuous cycle. And that's the beauty about container technology. Now, this technology is really becomes at a different level when there is a container orchestrator involved. And that's where Kubernetes comes into play. So meaning that you have this orchestration piece that can scale the container based on the needs and based on the pressure. So a container in itself will sit there like a single piece, but what if, for example, you want multiple containers of a specific application? What can, based on CPU pressure, memory pressure, can you do that automatically? Yes, you can with Kubernetes. So let's talk about what Kubernetes is. Especially when you talk about Kubernetes, you're talking about the Kubernetes cluster. So Kubernetes cluster is pretty much in charge of container orchestration, to say it for lack of a better term. Now, of course, if you were to dive into Kubernetes, for example, if you were to say, hey, I want to get the certified Kubernetes administrator certification, you will learn a lot more. It's a lot more complicated. But in a nutshell, very simply, it is a container orchestration tool, framework, technology framework. Now, when you talk about Kubernetes cluster, you're talking about the master node and the worker nodes. Now, each one of these nodes, the master node controls the entire cluster. And it monitors, as you see here, it monitors the distribution of work and also monitors the cluster health. So, when I say a node, multi-node Kubernetes cluster, what do I mean by node? A node is what runs the containerized applications. So those containers are placed on a node. Now those nodes can be either VM or physical machine. Now majority of people are working with VMs and node pools and things like that, for example with Azure. But you can technically have 3, 4, 5, whatever number of physical machines you can afford and create a Kubernetes cluster. Now of course that limits you, but that is possible. Now you see there the second bullet is pods. Now a pod is a logical group of one or more containers and associated resources. Now you might be wondering, what? What does that mean? That confuses me. Now a pod runs on a node, and a node can run one or more pods. Now I will be very, very honest with you that when I was first putting this presentation together, this was, I would say, a year and a half ago, if not a little bit more. And this was really confusing to me. This whole concept of a pod can run on a node and one or more pods, it was very, very confusing. So I had to create an image to hopefully assist with the visualization of what this represents. So let's talk about that. So this is my image. Please do not laugh. I am not that big of an artist, but I tried to put it together. So let's start from the left side here. You have your image file. And let's say SQL Server is an image file. And you were to download that and it becomes a container. So when you download it, you're running the Docker command to instantiate that image. Now it becomes a running container. Now people can access it. Now what does Kubernetes do? Kubernetes is the blue objects right here. It'll take these containers and put them in pods. And it'll take the pod and put it in a worker node. So this is a VM or a physical machine, right? And each one of these is a pod. Inside the pod are multiple containers. We'll talk about that in a couple seconds here. And then the worker nodes are combined into a cluster. So you see the master node and the worker nodes, and inside the worker node you see multiple pods. So two things I want to say here. Number one is you can only have one image per one container. So it's a one-to-one relationship. You cannot have two images of two different services running in the same container. For example, you cannot have SQL Server image and then, let's say, some type of web application service running in the same container. Those will be separate containers. Now you can have multiple containers in a pod. As you see here, you have one is running the Spark service, one is running Hadoop or HDFS, for example, in here, and one is running SQL Server. They can all be connected in a single pod. Now, why would you do that? You would want to make sure you design your application or your cluster in a way where like services are in the same pod. So in case you're wondering, well, what do you mean? For example, imagine if you have SQL Server running in a container in a pod, but you also want another service that runs that will collect metrics. You put that service in the same pod, different container, but same pod. So if that pod was to terminate for some reason, there's something wrong with it or something where it corrupts or something and it dies out and it terminates, both of those services can terminate and everything will be okay. So, because they're dependent on each other. If there's no SQL Server, then there's no metrics. So you definitely don't want something like the front end and the back end services running in the same pod. So if it dies, oh my goodness, the entire thing goes down. That's what you don't want. So all of this discussion of containers, Polybase, Kubernetes, and the question becomes why? Why? And for me, if you are like me, you really want to find out the why. You really need that motivation to get up and pursue some cutting edge technology. It takes your time, takes time away from other things you can be doing. You can be spending time with family, or you can just be watching Netflix. You can be just doing something else. But why is this so important, and why is it relevant for us? I want to share a couple pieces of statistics that I came across that really opened my eyes. And the first one is this one right here. 90% of all data today was generated in the last 2 years. Can you believe that? By the way, this statistic was not this year. This was a few years ago. So that number is most likely increased from 90. So really think about it. When I can see the audience, I ask, what do you think is generating all this data? What is behind this exponential growth of data? Excuse me. And I give them a second. And they usually say, overwhelmingly, a lot of people, the majority of people say, social media. Social media is the one that's generating all this data. And you are absolutely right if that's what you thought. Now, some people say IoT devices, and yes, that is also generating massive amounts of data. But social media has been around a lot longer and generating a massive amount of data. And in comparison to IoT, IoT is fairly new in the game. But I say within the next 5-10 years, I mean, the amount of data being generated just unbelievable. So I want to share with you another piece of statistic. This just really blew my mind. Walmart And if you are living in a country where you do not have Walmart, but you probably have heard of Walmart. Walmart collects 2.5 petabytes of data from 1 million customers every hour. Every hour! 2.5 petabytes. Billions and billions of Facebook messages, tweets, YouTube videos, comments, etc. And you might be wondering, what do they need all that data for? Walmart has data on over 150 million people. What do they need all this data for? For what? Why do they need Facebook messages? Why do they need tweets? This is the beauty about this era, this big data era that we're living in, that we can just hoard. Disk is cheap, and you can just hoard all this data, ingest it from all the different social media sources, the internet. It's like they're downloading the internet, and you can store it. But what do you want to do with it? That's the question. Now, if you all remember, about a month ago, maybe a month and a half ago, the big thing with Walmart and even Microsoft was TikTok. They wanted to buy TikTok, or at least I believe they wanted to break it up, or they have the US, I can't even say it, TikTok, the TikTok version in US to be owned by a US-based company. So Microsoft was wanting to purchase it, Walmart, and then later on, if you all were paying attention to it and really cared about it, Oracle got into the game. Eventually, Microsoft pulled out, and Oracle, I believe, won the bid, and in partnership with Walmart. Now, I want to take you back to the previous screen. Now, you see that they collect all of this, and now they're going after TikTok. Now, do they care about, or rather, what do they care about? Why TikTok? Because TikTok is one of the fastest growing, one of the biggest social media platforms for the demographics between the ages of 13, 14 to let's say mid-20s. They can analyze so much of this data and target market. And I want to leave you with a quote from the Walmart CEO back in 2013. I'll give you a second to read that before I chime in. We want to know, that's what Walmart CEO is saying, we want to know what every product in the world is. We want to know who every person in the world is. We want to have the ability to connect them together in a transaction. Now, how are you going to do, we want to know who every person in the world is. Tiki-Talkie, that has all the people right there for you. And I implore you, if you have not heard of Walmart Labs, not Walmart the company, Walmart Labs, whole different subsidiary. All the data that's being generated and collected and analyzed is done by Walmart Labs. Go to Google or Bing and just type in Walmart Labs jobs. And look at the jobs that they have opening. Data scientists, data analysts, all these smart people, a lot smarter than me. And that's what they're doing. So, just to give you, and the point of these statistics and this quote is just to show you the amount of data. Now, your organization might not be dealing with big data, but that doesn't mean that it's not being collected at other companies, or that eventually might not, your boss might not come down to you and say, hey, I want big data. And then you're stuck with what? So at least you have the idea that potentially that's eventually maybe all companies will have some type of big data solution. So what does that have to do with SQL Server big data clusters? SQL Server comes out of 25 years of just being a relational database engine. All of a sudden it's saying, pick me. I can help you process this type of data, analyze it, model and serve it. I can help you with that. Have you heard of big data clusters? And that's what we're going to talk about, big data clusters. Now, the definition that you can see, this was taken from the Microsoft documentation, is BDCs, or big data clusters, allow you to deploy scalable clusters of SQL Server, Spark, and HDFS containers running on Kubernetes. So that goes back to the image that I showed you about the different services, containers running in the pods. These components are running side by side, like in the image. to enable you to read, write, and process big data from T-SQL or Spark, allowing you to easily combine and analyze your high-value relational data with your high-volume big data. Now, T-SQL and Spark, similarly to how you use T-SQL to access and to query data in SQL Server tables, Spark Engine is used to allow you to query data in HDFS or Hadoop distributed file system. You can use Spark SQL, you can use Java, Scala, R, and it is an in-memory technology, very, very fast, and that's why it's the de facto engine when it comes down to querying big data, mainly in Hadoop or HDFS. So if you want to look at an image, starting from the left-hand side, this entire middle section that you see right here, this ingest, store, you bring the mouse into here to kind of help. This all right here will be your SQL Server Big Data Cluster. It turns into an AI and ML platform with SQL Server 2019. That's amazing. You have your logs, your files, your media, whatever's coming in unstructured. You're going back to that IoT, unstructured devices, sensors, and all that. And also your structured data coming in, ingesting it through whatever you want, Spark Streaming, Kafka. You can store it into your SQL Server data pools or HDFS, again, your Hadoop distributed file system. And then you can use Spark, Spark ML, machine learning services within SQL Server to analyze it. I like to say that the smart people come in here, your data scientists, your data analysts, and you run your Azure Data Studio notebooks and model and serve it, all within SQL Server Big Data Clusters. Let's talk a little bit about the architecture here. Now, to give you a bird's eye view, this image was taken from Microsoft. All I did here was I bolded the green, the black, and the red. So the green here is the actual big data cluster. The black are pools, so you have your compute pool. And then your red are the pods. So you have your compute pool, your data pool, your storage pool, different pools inside of the big data cluster. So what Microsoft has done is created this cluster with these different pools, and all a pool is, nothing complicated. All it is a logical grouping of like services. So for example, you have your compute pool here. So all the pods within this compute pool only do compute. Very, very simple. Your data pool, all the pods in here are doing your data caching, data persistence. We'll talk about that. They don't do any computation per se, right? So these are just grouping. Those pools just mean groupings. Now this controller actually should be inside of this big data cluster because there's a controller. And the controller controls everything, just like the name suggests. And you have open source tools like Kibana with a backend of Elasticsearch. You have Grafana with InfluxDB. And Kibana and Grafana are open source reporting, metrics collections and log search. So if you wanted to check out logs of your big data cluster, all types of logs, you will log into Kibana and you just bring up the browser, log in, and it's just like entering a search engine. Bing or Google, you have your search bar, and you can type in and search whatever you want. It'll go look through all your logs. Grafana is like a metrics dashboard. So if anybody uses, for example, one of the third-party metrics dashboards for, let's say, SQL Server, Grafana just like that, but it's open source. You don't pay for that. Kibana, Grafana, these are all open source. So let's kind of talk about each one of these objects within the big data cluster, and we'll start with controller. So the controller hosts the core logic and deployment and managing of the big data cluster. So when you deploy a big data cluster, the first thing that is deployed is a controller. And it takes care of all interaction with Kubernetes, SQL Server, and different components like HDFS and Spark. So the controller is part of that. Manages the cluster lifecycle. Again, when you bootstrap the cluster, you delete it, update it, the controller takes care of all of that. manages the master instance. We'll talk about that, SQL Server master instance. And then again, the different pools like compute data storage pool, and manages cluster security. Now the master instance, now let's kind of go back real quick here. The master instance architecture right here. This right here is a master instance. This is the only thing that we log into as a data professional. Your custom apps, the BI tools, anything, connection strings, they go into this. This part is abstracted from us. We don't really see this. I mean, we can create external tables to the data pool, but we don't, when you log in, we log into the SQL Server master instance. So let's see what that does. Go back to master instance here. So again, it provides that external accessible endpoint for the cluster. You can connect via ADS or SSMS, Azure Data Studio. Now, a lot of us data professionals, we are mainly using SSMS. Now, I remember when I first downloaded Azure Data Studio, I downloaded it, this was like 2 years ago. I downloaded it, I installed it, I opened it up, and then I closed out and I uninstalled it. I had no idea. I thought it was an unfinished product because I was so used to SSMS and all the different options and tools and things that you can use right there. ADS or Azure Data Studio is very cut down, trimmed down, skeleton version. But it works off of this concept of extensions. So you can extend it based on what you need. So when you download Azure Data Studio, you can install the SQL Agent extension. You know, the Profiler extension. You can download these things. So that's why when you download Azure Data Studio, it's very lightweight. It's like 80 megs or 85 megabytes. Very, very lightweight. I really encourage you to download Azure Data Studio if you have not, the latest version. And you can actually have a wizard, a big data cluster deployment wizard. I've created blog posts on how to do this. You can just go to my website. I'll show you all the links at the end and walk through the deployment process. And I'll hold off on that. We'll talk about that towards the end. So you have your scale-out query management on the master instance. Also, the machine learning is running. The service has to be enabled on the master instance. The compute pool, like we mentioned, is for computational resources. Very straightforward, just like as the name suggests. So the pods in the compute pool are divided into SQL compute instances for distributed queries, specifically Polybase. So the main role is to perform intermediate joins aggregations of multiple external tables. So if you create a table from Oracle, you create an external table, and you want to query that table, and based on the algorithm, it'll do the push down compute to the compute pool. So the master instance doesn't have to do that. It can, do something else. It can distribute the load, and that's what that's meant for. The data pool is used for persistence and caching. So when you create that external table, you can persist it. If not, it's cached. So when you go at it again, it's in the cache, and you don't have to go back over the network and connect to that server, to whatever, so Teradata, Oracle, ODBC connection, whatever, and pull that data all over again. It's done there. So the whole point of the data pool is for Data Marts are persisted to the data pool. Now, one thing I do want to say is that you cannot, when I say cached, you cannot access the cache per se, so you cannot modify it and access it. You can just access it via the master instance via just doing a select on the table or querying the table. Now, storage pool consists of pods of SQL Server on Linux, Spark, and HDFS. So these work hand in hand. So when you are ingesting data through Spark, that is all stored in the storage pool, sharded across the nodes for persistency, and you can access it through HDFS endpoints and also SQL Server endpoints. Now, all of this, and one thing I do want to mention with Kubernetes and storage. The concept of storage, especially with persistent storage, is very interesting with Kubernetes. And I want to bring your attention to this image right here. Let me bring the mouse here. Now, this was taken from the Microsoft Azure Kubernetes Service Cluster documentation site. And all I did was I bolded the red for persistent volume and persistent volume claim. So what happens with storage is you provide or you present storage to the cluster, to the Kubernetes cluster. Now, in this case, you have, let's say, premium storage, standard storage. You can have your pure storage, net app, any type of storage that you have, you present it. And they all, by the way, all the different vendors have their Kubernetes plugins. So you present the storage as a volume to the cluster. So the cluster has access to it. Then you create a persistent volume object in Kubernetes and says that this storage right here, NetApp, Pure, whatever storage, Azure files, will be persistent. It's a type of persistent volume, meaning it's not going anywhere. Meaning that if the Kubernetes cluster was to restart, reboot, the storage is not going anywhere. Versus, let's say, local storage, which it would be wiped out every time the pod is regenerated or restarted. It would wipe out the local storage. But this is persistent volume, so that means it's not going anywhere, and that's what you need when you're dealing with data. So you create that, and you tell it, okay, you can find the storage here, and the overall persistent volume size will be, for example, 1 terabyte or 1 petabyte, whatever the volume is, the requirements are. And then you create a persistent volume claim, and you say that this pod will need a claim to this persistent volume of about 500 gigabytes, for example, whatever the storage amount is, or the entire amount. And then the cluster master keeps track of everything. So every time the pod that's inside the node, let's say the SQL Server pod, needs storage, it must have this claim on this volume, and everything is checking out okay, then you have the volume. Everything is working. As they say, everything is gravy. So that's how the storage works. It orchestrates the storage as well as orchestrating the pods. So this is just the verbiage of what I mentioned. So if you were to download the slide deck, you have it. You can look at it. BDC endpoints or just security. There's only 5 ways to get into a big data cluster. You have your Azure Data or AZ Data CLI command line tool you download, and you can access it via the command line. I'll show you an example of that in the next screen. You can control access the controller. And then your different services you can connect through these different methods. So your management proxy, your dashboards, HTTPS, meaning that you will get endpoints to connect to and log in. This TDS connection is a regular SQL Server protocol you can log into via the TDS protocol. SQL Server master instance that we mentioned, you go into Azure Data Studio, SSMS, ODBC, or ADO.NET. Any type of connection you want to get into your big data cluster in SQL Server, you use the TDS connection. And then also your app proxy. So I want to show you a screen. This is a snapshot of my PowerShell, but I had SSH into one of my controllers, the master node of my Kubernetes cluster. And you run this command here, AZData BDC endpoint list O table, and it prints out all the endpoints for each one of these services. You can see all these different services. Log dashboard, I just have to highlight that, put it into the browser, log in, and I have a wealth of information there I can access. Now I want to bring your attention right here. SQL Server Master Instance Front End. I take that IP, I put it into SSMS or Azure Data Studio, and I log in. And I see everything. I see, just like you log it in to a regular SQL Server instance, you see everything. Now the beauty about Azure Data Studio, another beauty about it, is when you log in Azure Data Studio to a SQL Server Big Data Cluster, you can actually see your HDFS folder and look in it, get a visual. You can't do that in SSMS, to my knowledge, at least at the time of this recording. So they might eventually integrate that, but as of right now, that option to be able to view your HDFS folder and all of your files in there is only in Azure Data Studio. So these are the 5 points of entry. Let's talk a little bit about the features. The biggest feature to me, and this is one that really got me super excited, was this data virtualization concept. This name was given intended to show that you can access all these different external sources and bring it into one little virtualized data layer or data hub. Allow users from multiple sources, query data from multiple sources via a single interface. That to me was very, very awesome. Now you can technically do this with just Polybase, enhanced Polybase. You can create data virtualization. But when it comes to processing with Spark and the integration and the big data cluster and all of that, that's just a cherry on top. So this allows you to create a data lake, so many different sources coming in or streams coming in of data into a one pool, your HDFS storage pool. And you can go from there. You have your Data Mart, different silos of data, and whatever hat that you're wearing, you can access that portion of data and not even mess with anybody else. And again, all from SQL Server, Big Data Cluster, SQL Server 2019. That's the beauty about it. Now, BDC licensing, I know this is pretty boring of a topic and can put some people to sleep, so I want to do this fairly quickly. But I have the meat of the information from the licensing guide here for you. So the master instance that we were talking about must have core licenses. And that is a generic two core pack cost, enterprise and standard. And you must have software assurance or a subscription. So what is the software assurance benefit? It provides you with a BDN core or a big data node core entitlement for big data clusters. Now, what does that mean? Let's give you a little image right here. So if you have enterprise licensing for big data clusters and you have 4 core master node, then you get 8 times that 4. So you get 8 times as many big data node core licenses as the number of licenses for your master instance. So you get 4 here that you had to pay core licenses for times 8. So they give you, well, they don't give you as part of the subscription, 32 licenses, core licenses that you can apply. This can be your storage pool, your data pool, whatever you want to distribute it at. And then the rest remaining, you have to purchase on a subscription base at $400 a year for a 2-core pack. It's pretty appetizing if you think about it. Now, standard licensing is just one time. So if you have 4 cores, you get 4 additional. So 4 times 1, you get 4 cores, 4 entitled, and then you got to subscribe to 44 others. This one. So that's pretty much a big difference between standard licensing and enterprise is 8 versus 1x. So if you want to do some type of hybrid solution, which you can, license mobility, whatever you have on enterprise standard on-prem, you just move it over to Azure. Very, very straightforward. I do want to say one thing, that the BDCs are more intended for on-prem solution, but I mean obviously you can do it on the cloud if that's your go-to, but just note that from the product team point of view, that this is more catered towards a solution on-prem. So yeah, now I want to leave you with with obviously if you're like me and you're new to Linux and all these different new technologies, the learning curve is pretty steep. And no, that's not a picture of me. I am not. I wouldn't be able to even climb a ladder. So, but so I'll leave you with the learning path, and that way, hopefully, you can pursue and start going down the path of becoming relevant again, right? So the whole point is becoming relevant. And my call to action to you is go to mohammaddarab.com/BDC. At least bookmark it. I have all of the videos. I have a YouTube page. I have videos. I have blog posts. This presentation, an Excel checklist that with links that I've used over the past 2 years, and some are free. Playgrounds, online playgrounds. You can just create play with containers, play with the Kubernetes cluster for free. It's there for you to check out. Books. Some are paid, like Pluralsight, different courses, different books. But these are things that I learned. I mean, you can go there as a starting guide for you. I really, really encourage you to go ahead and do that. Feel free to reach out to me. Again, I do thank you very, very much for attending this. Hopefully the time comes fairly soon that we can actually meet all in person. That would be super duper exciting, and I'm probably like you all, and I'm looking forward for things to going back to normal, where we can actually shake hands and see people in face to face and just connect that way. Again, thank you so much. If you have any questions, since this was a pre-recording, feel free to reach out to me on Twitter at MWDarab or at MohammedDarab.com. Again, just reach out to me. If you have any problems, you're going through one of my blog posts, you're trying to deploy a big data cluster, you come across a problem, maybe one of my blog posts are outdated, I'll have to reach out to me and I'll help you out, because I feel like Kubernetes is the underlying technology that's going to be used for a while. Azure Arc, big data clusters, VMware is using their Red Hat OpenShift, VMware Tanzu. They all have their underlying Kubernetes framework that's running those technologies. So very, very important to learn. Again, thank you so much, everybody. Hope to see you soon at an event, or reach out to me online. Thank you so much, and good luck. And yeah, stay safe and stay healthy. Bye-bye.